Hey, welcome to this video for graphing quadratics in standard form. This is my second example. I ran out of time in my first video, so I didn't want to rush it. So here's example 2. So standard form, ax squared plus bx plus c. We need to graph this guy. So the first few questions I ask you, does the quadratic open up or down? And remember, it depends on this first value of a. If a is positive, it opens up. If it's negative, it opens down. So since it's a positive 4, we are opening up. So that means our graph is looking something like this. So then do we have a minimum or a max value down here at the vertex? We have a minimum. I'm just going to circle it instead of rewriting it. This guy finding his vertex, if you remember from the previous video, I need to use the formula x equals the opposite of b divided by 2a. So real quickly, let me label a, b, and c. So then x would equal the opposite of b, so that would be negative 4 divided by 2 times my a. So x is going to be negative 4 on top, and 2 times 4 is 8 on the bottom. Now that's a fraction that I can reduce from negative 1/2. All right, so we've got a fraction. Whoa. So the x value is negative 1/2. I've got to find the y value so I can have my coordinate point for my vertex. How do I do that? Blah, 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 blah. I plug in my x number into the original function. So let's see. So there I've plugged it in. For every place that you see an x, I put negative 1/2 in its place. So yes, you have to evaluate with fractions, but it's okay. If you use your calculator, it'll do all the work for you. Make sure you use parentheses though. And I believe when you do this, you should get negative 16 as your final y value. So our vertex is negative 1/2 comma negative 16. So the y-intercept, if you recall from the previous lesson, I know that x is always 0, okay? Because if you think about the coordinate plane, you know, this is my x-axis, this is my y. The y-intercept is always on the y-axis. So if I think about that point, yes, y changes, but x is always 0. Okay, so that's y. X is always 0. So let me plug that in for my x. And if you need to type it in your calculator, you can. If you can do it in your head, cool beans. We should get the value negative 15 when it's all said and done. So this would be my y-intercept point. The axis of symmetry, we said that's a line and we give the equation for that line saying x equals what though? Well, remember the vertex, we got negative 1/2, negative 16, and we've had the discussion that we borrow the x number from that vertex, and I use it for my axis of symmetry equation. And so that's it. That's all I'm looking for the axis of symmetry. So the one last thing are the x-intercepts. And so if we think about, again, that coordinate plane, where this is x and this is y, x-intercepts are points on the x-axis. So if I grab this point and I move it along the axis, yes, x changes, but y is always 0. So this time, here's what I know about the point, that y is always 0. So f of x is like my y, so that's where I'm going to plug in my 0 at. But when you do that, you might realize, hey, this doesn't really look like it helps me a lot, for Pete's sake. So what am I supposed to do? Well, it should look familiar, even though it doesn't look helpful. We're supposed to use either XPuzzles, divide and slide, or the quadratic formula to factor this guy or solve it. So because of this 4, if we were to factor, it would be a divide and slide method. So let's try to factor and see if it works. So divide and slide, we take the first times the last. And we get 0 equals, remember we dropped the 4, and we change this to the whatever the product is, and we get negative 60 when I multiply. And then from here, I do an X puzzle where I've got negative 60 on the top and 4 on the bottom. So what multiplies to negative 60 adds to a 4? I'm thinking 10 and negative 6. Okay, so those two numbers make up my groups for factoring. So 0 equals x plus 10, x minus 6. Okay, but now this is divide and slide. Have I even divided yet? No. So I got to go back and divide by that 4. That 4's got to come back in, and here's where it does. But you've got to make sure that you reduce these fractions. I've noticed on some quizzes we are not reducing. Make sure you do. So 10/4 you can divide out of 2, and that reduces to 5/2. And 6/4 reduces to, let's see, I could divide out of 2 again, and I'd have 3/2. Okay, so because that equals 0 is there, that signals that I'm solving. So I can't do anything else with 5/2 and 3/2. So we slide. Remember the method is called divide and slide? So I slide the bottoms up. And here are my two new groups. 0 equals 2x plus 5, 2x minus 3. Alrighty. Now, I branch here and I set each one equal to 0 individually. 2x plus 5 equals 0. And 2x minus 3 equals 0. Then I do a little bit of solving. So I move the 5 by subtracting. And I get 2x equals negative 5. And then divide. X equals negative 5/2. Okay. And then over on the other side, I would add 3. And then what would I do to get rid of the 2? I would divide. And so x equals positive 3/2. Okay, so what are these values? These give us points. Remember, we're graphing, so we want coordinate points. So these give me 2 points. Negative 5/2, 0, and 3/2, 0. Now, since we got fractions, you may want to take a second and plug those in your calculator. Use division instead of the ABC button to get the decimal values. Or if you know the decimal value, just know that negative 5/2, that's equivalent to negative 2.5. And 3/2 is equivalent to 1.5. So that way when we get to our graph, on the number line, you'll know where to put your points. Okay, so these two things in the black are the two x-intercepts. So the last thing we have to do is to graph this guy. So I'll do a quick sketch. My vertex was negative 1/2, negative 16. So negative 1/2, negative 16. And my y-intercept was 0, negative 15, so roughly here. Now just remember, we said we wanted this graph to open up, so which point does it make sense to reflect, the red one or the blue one? And if I reflect the red one, it would open down. So we always want to reflect our y-intercept. So remember that axis of symmetry goes through our vertex. And so we're going to reflect this blue one over to the left, and we get a new additional point that's reflected, and it's at -1, -15. And then I have my two x-intercepts that I still have to graph. Remember, we had -2.5. So let me plot a point here. And we also had +1.5. So my other point goes here. Okay, so I'll label those as 3/2, 0, and -5/2, 0. And then I just need to connect my points to make my U shape. And there is my quadratic graph. So if you have your note sheet from class, or you could go to my webpage here and download it, the Graphing Quadratics in Standard Form. The last column is the assignment. So keep learning, guys, and I will see you next time.